Hello, I hope you are doing well today. Today we are going to look at arithmetic sequences, which is covered in Year 12 General Maths in Term 1. And there's a question that scares a lot of people, and we're going to go through that. So our learning goal today is to find the first three terms of an arithmetic sequence when T1 or D are not given. Let's check it out. So first of all, arithmetic sequences. This is an arithmetic sequence here. They have two things about them. They've got a common difference, D. So here, D is 3. So a common difference means just subtract the first term from the second. You've got this common difference. So I'm going to write D equals 3. And they also, arithmetic sequences have a first term, T1, which is sometimes called A. So in this arithmetic sequence, we know that T1 is the first term, which is 4. So that's all they are. And this is the bit of information that I want you to lock in your mind in regards to arithmetic sequences. So we know this bit from the previous slide. Think arithmetic sequences, think D and T1. And we also have two formulae available to us. So I'm quite sure this one is given on your formula sheet, the rule for the nth term. And this one is not. So you're going to want to memorize this one. Okay. But so I would copy these down if you can and just refer to them as much as possible. So this recursive formula is used if you're given the first term. You need to be given the first term in order to use the recursive formula. So recursive formula is the next term equals the previous term plus the common difference. So all that is in numbers is you can generate the next term using the previous term. I always remember it as that. This number, the number on this side is bigger than this side, the term number. And then you just keep iterating, plugging the last answer into the next one. And we're going to see how to do it. So, you use this recursive formula to generate a sequence. You use this rule for the nth term and I will show you how we use it soon. So just make sure you copy these two formulas down and know the difference between both. And notice that the recursive formula has this weird Tn plus 1 equals blah. And the rule for the nth term just has Tn in terms of there. And let's just give it a go. So, bit of a tricky question, but not really. In an arithmetic sequence, the 5th term is 10 and the 9th term is 18. Find the first 3 terms. First thing I would do, okay, underline your keywords. Arithmetic sequence, well, that means we need a T1 and a D value. 5th term is 10. I'm going to translate that maths as, let's put a little data table here. The 5th term, T5, is 10. Make a data table. Okay. Now there's something that I can also get out of that. Another bit of information is n equals 5. Okay. Since Tn. So that's what you also want to drag out at this point, that implies that n equals 5. So that's our first bit of information. Our second bit, the 9th term is 18. T9 equals 18. And for that bit of information, n equals 9. A lot of people mix up here. They say n is 18, get all confused. But it's all good. Just write this straight down. So we need to find the first 3 terms. So we want to find T1, T2, T3, which is ringing recursion bells to me, right? That's how you generate terms. Nice and easy. But let's do it. Okay. Bit of a different one. So we are going to start by using this rule. I'm going to write it down. So the rule for the nth term, Tn, just writing it out, t1 plus n take 1 times d. And we're going to form two equations. See how we've got these two bits of information? We've got this one and we've got this one. So let's form an equation. Okay, I am going to actually just move this around a bit. It's a bit different. So let's use our information. Tn, okay, I'm going to use it, T5, whoops, equals T1, okay, we don't know T1, plus N, well, we've got our bit of information here, N equals 5. Take 1 times, and we don't know D. That's the weird thing about this question. We don't know A or D, what T1 or D. All right, the other bit that we can draw from this is T5 actually has a value, because I look here and I'm like, oh my God, there's so many unknowns. We've got T5, we've got T1, we've got D. How are we possibly going to solve this? Well, actually, remember, we have a value for T5. We have a value. T5 is 10. Sub T5 is 10. And then you can just simplify it a bit as you go. 5 take 1 is 4. So simplifying those brackets. And then I have my first equation. So what we're actually aiming to do, we have two bits of information. We can form two equations with two unknowns and solve them simultaneously. Yeah, it's not, it's a bit different, all right? Okay, let's form our second equation. Okay, if we have, see how we've got now two unknowns here? Let's try and form a second equation. Okay, again, maybe I'll write the formula. Tn equals T1, the formula for the nth term. And then let's use our information. Tn, okay, well this bit of information is for T9 equals T1. Unfortunately, not given T1 in the equation. Plus this valuable bit of information. N is 9. T9 means N is 9. T5 means N is 5. And we don't know D. And we get here again and we're like, oh, there's 3 unknowns. What do I do? You panic, but then you realize, okay, look, I have a value for T9. So sub T9 equals 18. And then just keep using it. So I've substituted that nicely. T1, don't know. Let's simplify in the brackets. 9 take 1 is 8. And D, we don't know either. So we have now formed our second equation. Okay, so the next step that I like to do, let's just rub out this. Let's move this down a bit too. I like to write the equations on top of each other. So we've got 2 equations, 2 unknowns. We can solve for these really important guys, T1 and D. Let's write our equations on top of each other. So 10 equals T1 plus 4D. That's equation 1. And we have got equation 2, 18 equals T1 plus 8D, equation 2. And I look at them and I can see, look, they're lined up perfectly to eliminate, to use that elimination method. I could nice and quickly eliminate that T1 if I wanted. And I don't want to end up with negatives, so I'm going to go equation 2, take equation 1. So you just line them up, make sure you go that way. So 18 take 10, 8. T1 take T1, 0. So cancel nicely. And make sure you keep going up like that. If you're doing 2 take 1, get the order right. 8 take 4 is 4. So in other words, 8 equals 4D, because that 0 doesn't matter. 4 times D, well, the opposite of times is divide. Do that to both sides. And let's go. 2, D is 2. And then let's move this over a bit. So now that we have this D is 2, we can substitute into any of the equations to find A. Okay, so, and then let's go sub D equals 2 into, just choose the simpler equation. I'm just going to choose 1. I'm going to get rid of that. That's confusing. Sub D equals 2 into equation 1. Let's do it. Okay, so 10 equals T1 plus 4 times 2. Just subbing up in this one. 10, let's simplify. And then if we want to just minus 8 from both sides, okay, to get rid of, and we'll be left with T1, which is nice. T1 equals 2. I've just switched the sides there. 10 take 8 is 2. All right, looking great. Put a box around it if it's going to be helpful. We come back to the question. It says find the first 3 terms. So we have used up this nth term formula nicely to form 2 simultaneous equations. Now, the easiest way to generate 3 terms, the first 3 terms or 5 terms, whatever, if it says the first few, use the recursive formula down here. Okay, so I reckon let's probably just go to a different page quickly. And we got D equals 2, T1 equals 2. D equals 2, T1 equals 2. And we're just choosing to use our recursive formula. And we're saying generate first 3 terms of this arithmetic sequence. And here we go. So using this formula, we know that T1 is 2. Let's define our recursive formula. And our recursive is just in terms of these little guys. Tn plus 1 equals Tn plus 2, because that's D. Substituting straight in. Okay, now let's use it. This first step people get confused by, but it's all good. You just want to remember that the next term is the previous plus the common difference. So in other words, if I start with T1, all right, I can calculate T2. I'm just going to put a box around that. T2, so the next term is the previous term plus 2. And then sub in your values. T1 is 2. 2 plus 2 is 4. So we've got T2, put a box around it. And then we do our next term. Okay, the next term, T3, will be our previous term plus the common difference. Okay, let's do it. I might just, yeah, that's all right. Okay, so we're working from our previous term. Plug T2 as 4 in. 4 plus 2 is 6. And can you see the pattern? I'll do one more just for good luck. We've answered the question already though. The sequence is 2, 4, 6. And let's do one more for good luck. Using recursion to generate the 4th term, we need to say the next term, T4, is the previous term, T3, plus or minus the common difference. And what was T3? Well, we can plug that in. So we're always working to plug in from the previous thing. So what do we got? 6 plus 2 is 8. And that would be the term 4. But yeah, running out of time. So that's how we generate it. So you'd say the sequence is 2, 4, 6. The first 3 terms of that sequence. So what we do, firstly, we used our rule for the nth term to get 2 equations and 2 unknowns. And then we solved it. But yep, out of time. Have a great day.